Hi students, Professor Gray here. Let's finally finish up the end of chapter 2. So last time we talked about the noble gas abbreviation and how that helps us save some time writing our electron configuration. The next slide that we need to do is this one right here. So we need to talk about some exceptions to the rules. So we teach you guys some rules and you get really good at following the rules and getting the right answers, and then we say, surprise, there's some anomalies. And here we are on that part of the lesson. So let's do the electron configuration for chromium. So chromium is a transition metal, and chromium is right here. So if we were to do the electron configuration for chromium, we would see that we would do 1s2, 2s2, 2p6, 3s2, 3p6, and then remember, after 3p6 does not come the 3ds. What we'll do is we'll go out to the 4s because that lovely spherical orbital is low in energy and really easy to get into and nice and comfortable. So those 2 electrons will pop out into the s subshell out there, into the 4s. And then we go back into the 3ds. So we have 3d something, and let me switch back to the periodic table to show you guys. So right here we've got 4s2, and then here we've got 3d1, 2, 3, 4. So for chromium we have 3d4. And that would be the electron configuration that we think that we would have. Now the thing about this is, when you half fill or completely fill the D subshell, it's very stable. So if we go back to the energy diagram right here, we can see that the D's are higher in energy than the 4s right there. But the thing about that is, once you half fill the D's, or you completely fill the D's, their energy level sinks. So that means they become more stable. So what's going to happen with chromium is this 3d right here. The D's are going to say, oh, if we just had one more electron, if we were 3d5, we'd be half full, and that would make us a whole lot more stable, our whole atom. And stability and low energy is good in chemistry. So what happens is the 3Ds say to the 4s, hey, if we could just have one of those electrons back, then we could half fill the D subshell, and that would give our whole atom a whole lot of stability. So the S is like, sure, and it sends one of the electrons over. And what happens is that we end up having 4s1, 3d5, okay? Now, again, why this anomaly happens is because it causes things to be more stable. So that's why if you look up the electron configuration for chromium, on the end we'll see 4s1, 3d5. Now, if we were to do the noble gas abbreviation for chromium, what we'd have to do is follow the rules, and we would back up to the previous noble gas, okay? And all the noble gases here are going to end in P6. Helium up here is going to end in S2. So we would write argon in brackets, because we want to say we've got the electron configuration for argon plus a little bit more. So we write argon in brackets, and then we would write 4s1, 3d5. So you can write the whole thing out, or you can write the noble gas abbreviation. Alrighty, going on to copper. Copper is right here. So it's going to have the electron configuration that chromium has, but it's going to have a few more electrons. So if we go from chromium, which is D4, before we did the whole give me an electron from the 4s, then we'd have D5, D6, D7, D8, and D9. So copper would have the same electron configuration as chromium, except for on the end it would be D9. So we would have 1s2, 2s2, 2p6, oops, I forgot the 6 up here, sorry about that, you guys. 3s2, 3p6, and 4s2, and 3d9. So what's happening there is we have nine electrons in the D, and all of these guys are filled down here. And the D's right here are talking to the S, and they're like, if you could just give us one of those electrons, we could be really stable, which means energy level goes down. And we really like that situation, and it benefits the whole atom. So the 4s is like, all right, I'll give you one of my electrons. And so what we end up with is 4s1, 3d10. And again, that's because it causes the atom to be very stable. And stability is good. If we wanted to write the noble gas abbreviation, we would write it like we did for chromium. We'd go, okay, all of this right here is argon. So we will write argon, and then we'll write this little bit on the end right there to indicate that we've got copper. Okay, so that's that slide. Now, moving on to the very last slide of chapter 2. Yay! Okay, so what are the electron configuration and orbital box diagram for phosphorus? So phosphorus is P, and if we look on this periodic table, we will see that phosphorus is the atomic number 15, so we've got 15 protons and 15 electrons. So we've got 15 electrons to place. And if we look at the periodic table, we can see that we've got 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so right in that back on the slide, we've got 1s2, 2s2, 2p6, 3s2, 3p3. Now the problem also says write the orbital box diagram for phosphorus. Now for an orbital box diagram, we have to actually draw boxes. So we're going to draw a box for our 1s, and we're going to put 2 electrons in there because it's 1s2, and then a box for the 2s, and then 3 boxes all stuck together for the 2px, 2py, and 2pz. And that indicates that all of those are at the same energy level. So if we go back to the diagram, you guys can see that the 2p's, they're all at the same energy. So we go ahead and we give the 2p's 6, so we're right here. And then we write the 3s orbital and we put 2 electrons in that one. And then we need the 3p's. So we have 3px, 3py, and 3pz. And there's 3 electrons that go into those orbitals. And remember, we have to distribute them evenly. So we have to follow Hund's rule. And where we saw Hund's rule was back here. Let's see, there's Pauli. Oh, here's Hund's right here. So electrons pair only after each orbital of equal energy is occupied by a single electron. So remember, you have to give each of your triplets a hamburger before you give any of them 2 hamburgers. So that's the orbital box diagram for phosphorus. So the electron configuration and the orbital box diagram are giving the same information, just in different formats. Okay, so what are the electron configuration and orbital box diagram for silver? So silver is way down here, so we're going to be in the 4Ds. So let's go ahead and do the whole electron configuration and draw all the boxes, which will take us a while, but it'll be a good practice. Okay, so we've got everything that we have for phosphorus except for we're going to 3p6, which is all the way out here. So let's go ahead and write that here. So 1s2, 2s2, 2p6, 3s2, 3p6, and then we are right here. So we've got 4s2, and then we're going to go through all the 3Ds. So we've got 3d10. Now we're going to do 4p6 and 5s2. So 4p6 and 5s2. And that puts us right here. Okay. And then we go to the 4Ds. So again, if you guys are having trouble remembering where all of the different subshells are, what they're called, what order we fill them with electrons, take a look at this slide right here, and it'll show you how the D's, the number on them, is shifted down one. So the 3s and the 3p are up here, but the 3d looks like it's in the 4 row. So all the D's are shifted down one. So for silver, we are right here right now. Okay, so we're heading on into the 4Ds. You can also do this chart right here, and you can see that we are right here. We're at 5s, and then we're going to 4D. So looking at the periodic table right here, we've got 4D 1, 2, 3, 4, 5, 6, 7, 8, 9. So silver is 4D9. Okay, so we have a situation where we have an S2 and a D9. So what's going to happen here is that the 4Ds over here are going to say, oh, we are almost full. And if we can get to D10, it'll cause the entire atom to become more stable. So, hey, 5s, can we have one of your electrons? And 5s is like, all right, if it's good for everybody, you can have it. And so it goes to 5s1, and then we have 4D10. So we would cross that out right there. Now, writing the electron configuration, the orbital box diagram for this one is a beast. So what we're going to do is we're going to continue on with the orbital box diagram that we drew for phosphorus. So let me just cross out phosphorus right here. And you guys can see that for silver, we go to P6. So that would mean that we would fill these boxes. we'd have 3p6. And then I'm going to write the rest down here, or attempt to in this space. And we have 4s2, we're right here. And then we have 3d10. And remember that your D's are going to come in 5s. So we have 3D, and then we have 4p6 right in there. So the p's, they come in 3s. 4p6. And then we're down here at 5s, and that 5s only has 1 electron in it. And then we have more D's. We have 4d10. So that's a lot of boxes and arrows to draw, but this combined with this right here is the orbital box diagram for silver. And that concludes chapter 2, my friends. Yay! On to chapter 3, finally. And no cat meowing and no dog barking or snorting or snoring. I hope you guys are doing okay. Please meet me for office hours if you have any questions or if you just need to chat, because I know that a lot of us are getting lonely at this point. I know I am, just me and the kids here. I miss you guys a lot. Okay, good night.